Welcome to the future of fashion, where discarded plastic bottles are transformed into premium, high-end luxury textiles.
Millions of tons of plastic waste pollute our oceans annually. But this factory offers a sustainable solution.
The journey begins here with raw bales of post-consumer plastic bottles collected from cities around the world.
Forklifts transport these heavy bales onto the primary conveyor belt, starting the automated and complex recycling process. A bale breaker machine uses metal teeth to tear apart the compressed blocks. The loose bottles tumble down onto a vibrating feeder table, which spreads them out for initial inspection. A large rotating trommel screen filters out small contaminants like dirt, rocks, and loose caps or glass. Next, the bottles enter a label remover, where friction and scraping blades strip away the paper wrappers. Powerful air jets blow the lightweight labels into a separate collection duct, while the heavier bottles continue.
Advanced optical sorters use infrared light to identify the specific polymer signature of every single passing bottle.
Compressed air nozzles instantly eject any non-PET plastic items, ensuring only pure material enters the next stage.
Despite high-tech automation, a final manual check is performed to catch any colored bottles or hazardous items.
The clear bottles fall into a wet grinder, where massive steel blades chop them into small flakes.
Water is added during the grinding process to reduce friction and begin washing the plastic flakes immediately.
The slurry moves to a friction washer, which spins at high speeds to scrub off stubborn glue. In the sink float tank, heavy PET flakes sink to the bottom, while lighter cap materials float. The skimmers remove the floating debris from the surface, separating the valuable polyester material from the waste byproducts.
The clean flakes at the bottom are extracted and sent to a hot washer for chemical cleaning.
Hot water mixed with caustic soda and detergent sterilizes the flakes and removes any remaining organic residues.
The material passes through multiple freshwater rinsing tanks to ensure all traces of cleaning chemicals are removed.
A centrifugal dryer spins the wet flakes rapidly, forcing moisture out through mesh screens to dry them.
Hot air blows the flakes through long thermal tunnels to reduce moisture content to absolute zero levels.
Lab technicians inspect samples of the dried flakes to verify purity and color consistency before melting begins.
The dried flakes are fed into a massive extruder, where a screw conveyor pushes them into heat. Inside the barrel, temperatures reach nearly 300 degrees, melting the plastic into a thick, viscous liquid. The molten plastic is forced through ultrafine mesh filters to catch any microscopic contaminants that survived washing. The filtered liquid exits the die head as long, thin strands, which are immediately cooled in water. A rotary cutter chops these cooled strands into uniform, rice-sized pellets, known in the industry as nurdles. These recycled pellets are stored in massive silos, ready to be transformed from plastic into textile fiber.
The pellets undergo solid-state polymerization in a vacuum reactor to increase their molecular weight and strength.
Strengthened pellets are transported via pneumatic tubes to the spinning facility, where the fabric creation truly begins. Once again, the pellets are melted down in the spinning machine, converting them back into liquid form. The liquid polymer is pushed through a spinneret, a metal showerhead with hundreds of microscopic tiny holes. Ultrafine filaments emerge from the spinneret and are instantly cooled and solidified by a stream of air. These individual filaments are gathered together at the bottom of the column to form one continuous yarn.
The raw yarn is wound onto bobbins at speeds exceeding 3,000 meters per minute, blurring vision.
Robotic arms automatically doff the full bobbins and replace them with empty cores to maintain continuous production. The yarn is sent to the drawing line,
where it is stretched between heated rollers to align molecules.
Stretching the yarn makes it significantly thinner and stronger, giving it the necessary durability for clothing use.
A texturing machine adds crimp and bulk to the straight yarn, giving it a soft, cotton-like feel. Air jets tangle the fibers slightly to create volume, ensuring the fabric will not feel like plastic.
Sensors monitor the yarn thickness and tension in real time, cutting the line if any defect is detected.
Finished spools of white recycled polyester yarn are packed into crates, ready for the weaving or knitting department. Forklifts transport the yarn to the massive weaving hall, where hundreds of looms create a deafening rhythm. Technicians set up the warp beam, aligning thousands of individual threads onto a massive metal cylinder drum. Workers painstakingly thread each yarn through the eye of the heddles, a process requiring immense patience and skill. High-speed airjet looms shoot the weft thread across the warp using bursts of air instead of shuttles. The fabric forms rapidly before our eyes as the machine weaves the vertical and horizontal threads together tightly. Inspectors patrol the aisles, checking the emerging fabric for any broken threads or knots that mar quality.
The large rolls of unfinished fabric, known as greige goods, are removed from the looms for processing.
Before dyeing, the fabric enters a scouring tank to wash away oils and sizing agents from weaving.
The material moves through a heat-setting stenter frame, which stabilizes the width and prevents future shrinkage. In the dye house, fabric enters high-pressure and dyes. Computers calculate the precise recipe of dyes needed to achieve the exact color requested by fashion brands. The fabric circulates rapidly inside the jet machine, ensuring the color is applied evenly without any streaking. The fabric emerges from the machine transformed from stark white to a vibrant and deep luxury blue.
Heavy rollers squeeze out excess water from the fabric before it enters the final drying and finishing stages.
A water-repellent coating is applied to the surface, adding functionality to the luxury feel of the textile.
The fabric passes through a final long oven to cure the chemical finish and lock in the color.
A brushing machine mechanically raises the surface fibers, giving the recycled plastic a soft, velvet-like texture.
Automated lasers trim the rough edges of the fabric roll, ensuring the width is perfectly straight and uniform.
The fabric rolls over a backlit table, where inspectors search for microscopic defects, holes, or color variations.
Any small flaw is marked with a sticker so the clothing manufacturer can avoid that section during cutting.
A sample swatch is cut from every roll and sent to the physical laboratory for rigorous stress testing.
The machines stretch the fabric until it tears to measure its tensile strength and ensure it meets safety standards. The Martindale test rubs the fabric surface thousands of times to ensure it will not pill or wear out. Technicians wash samples to check for color fastness, ensuring the dye does not bleed onto other clothes. Once approved, the massive rolls are wrapped in thick, protective plastic to prevent damage during the shipping process. Labels are printed with QR codes that allow brands to trace the plastic back to the original source. Forklifts load the finished rolls into shipping containers, destined for fashion houses in Italy, France, and New York. The journey continues in the design studio, where fashion creators marvel at the soft touch of recycled plastic. Pattern makers cut the fabric into shapes, preparing to assemble garments that are both stylish and environmentally responsible.
Skilled tailors stitch the pieces together, creating high-end jackets that look identical to those made from virgin materials.
On the runway, the final product is showcased, proving that sustainability does not mean compromising on style or luxury.
The contrast is striking.
A piece of trash that was once pollution is now a symbol of modern luxury.
Back at the factory, the water treatment plant ensures that every drop used is cleaned before release. Solar panels cover the roof, powering the energy-intensive melting and spinning processes with clean, renewable energy from the sun.
The human element remains vital, as
A display in the lobby showcases the 3 stages of transformation, from dirty flake to pellet to yarn. This single facility saves over 50,000 tons of plastic from entering landfills or oceans every single year.
Research continues daily as scientists develop new blends, mixing recycled polyester with organic cotton for better comfort.
Under the microscope, the recycled fiber is indistinguishable from virgin polyester, possessing the same strength and durability characteristics. For the consumer, the recycling logo on the tag is a badge of honor and a conscious choice.
Buying these products drives the demand for recycled plastic, encouraging more factories to open around the world.
The factory runs 24 hours a day, a tireless engine in the global fight against plastic waste pollution. As long as people consume plastic beverages, this factory will have the raw material needed to keep running. Another truck arrives at the gate, bringing more waste that will soon be given a second life. The cycle is continuous, a circular economy in action, where waste is viewed as a valuable resource. The transformation from a clear bottle to a white pellet is the critical step in this industrial alchemy. The second transformation from pellet to thread bridges the gap between the waste industry and the fashion world.
Engineers are already planning to expand the facility to handle different types of plastics beyond just standard bottles.
This facility demonstrates that industrial processing can exist in harmony with the environment when managed with strict care. From grinding to washing, melting to spinning, every machine plays a vital role in this complex symphony. The result is a fabric that is soft, durable, breathable, and indistinguishable from materials made from crude oil.
Ideally, we would use less plastic, but recycling remains our best defense against the waste currently in existence.
As the shift changes, a new team takes over, ensuring the recycling process continues without a single pause. 100% recycled, 100% sustainable, and 100% the future of the global textile industry.
Thank you for joining us on this journey inside the high-tech world of plastic-to-fabric recycling manufacturing.
We hope this glimpse into the process inspires you to recycle and choose sustainable products in your life.
For more documentaries on industrial processes and sustainable technology, please subscribe and join us for the next episode.